Welcome to all. See, before anybody will go through this class, it is compulsory that they should go through last class. Because last class, that is Engineering Mechanics Part 4, Lecture 5, I gave a puzzle or I told a brain teaser or hidden concept. That is last 30 minutes of that class, around 30 minutes, I don't know. Once I completely solved the question, I explained, see, once I got this answer, where is answer P10.5, this was already over earlier. Then I asked a puzzle. After the puzzle, I continued question 6 and 7. The puzzle is for question 1 of very, very important basic questions. I put title last time. Before that, I put the title. First class question number 1, 2, 3, 4 over. Next, that is in lecture number 4. Lecture number 5, I first gave the puzzle for which one example required. I selected the question 1. Then after the puzzle is over, not last 30 minutes. So not last, around first 30 minutes, not last, first 30 minutes, First I asked the puzzle, then I went to last time, then I continued. Therefore, remember, anybody who is going to this class, they should go to previous class, lecture 5, you should know what is the puzzle. Then only it is useful for you. Okay. First of all, I asked so many people to put comment. Few comments came. In the YouTube only one comment came. It is correct, but it is not satisfactory. When you put a comment, just telling one sentence is not correct. Some justification required. Because I will tell the answer for the puzzle, some will be knowing. So many places they might have told it. So even if you heard it also, you can tell that one. I will tell you correct comment what you have tried. And even my known students, 1 or 2, personally to my number, they are in the batches, some courses there. They told the answer. One of them correctly told, but not fully satisfactorily, somewhat correctly. And before that only, I decided. I told this puzzle, I will put, see, in the YouTube, in my channel, in the playlist, you can see brain teasers, puzzle or hidden concept. Some 3 are uploaded. They are beautiful questions. So far, nobody gave a single answer. See, those who want really, they know subject, answer those questions. This is very simple. Then I told, I will upload this one there and give solution there later. Then I decided, first of all, this puzzle what I am asking, is it worth to put it in that brain teaser? No. This is very, very simple. I decided in that brain teaser, I want really brain teaser. Ordinary people or even little higher level, they should be stunned by looking at the question. They should not be able to solve the question. Only with a very high level knowledge, they should answer. Therefore, I thought, this is so many will give the answer. So I thought, this does not deserve to be called a beautiful brain twister question. So I decided to give solution in this class today. I'll give the answer now. See, because this puzzle I asked, it does not have that much merit to be included in the brain teaser question. See, later, so many brain teaser I will ask. See, one after other one. So many, more than 30, 40, 50 it will be there. Let me see, not so far, not a single one answered it. Okay. Now, see, class. The question was, I read the question. Actually, already you go to part 4, lecture 5, you can see that one. A rectangular block weighing 30 kilonewton is placed on a rough horizontal surface. Then, coefficient of friction for the contact is 0.35 in the given question given. Then, a lateral force, horizontal force, pushing force P is applied. Question was, find the least value of P required to move the block. Then I told, okay, see, now brief solution once again today. Find the least value of P required to move the block means I told understood. See, the answer came 10.5. At 10.5 it will not move. It is on the verge of moving. See, so any force which is more than 10.5, it will move. So the least value is 10.5. Actually, 10.5, 0, 0, 0, 0, etc. will move. Or technically, so many question paper, when they ask find the least value of P to require to move the block, means you should consider the case of limiting equilibrium. See, I told consider what? Limiting stage. I told already. See, you write here. Brief solution. In the class, I told consider limiting static friction case. I told it. I won't write once again. That is your FF frictional force equal to mu into normal reaction. And now, how I solved? Consider equilibrium of the block. Why equilibrium? Because we considered block on the verge of moving. Remember, on the verge of moving, still not yet moved. You can write here, not yet moved means it is still at rest, but it is about to move. Therefore, still equilibrium is maintained. So, for equilibrium, conditions are sigma fx0, sigma fy0. These are the two force equilibrium conditions. Lastly, sigma m0, algebraic sum of moments about, see, I told all about any point should be 0. Okay, these are the conditions. Okay, then we solved. What you have done? See, 30 downward, normal reaction upward. See, when the block is pushing the surface down, reacting force R will act on that one. This is action, reaction. Same way. Action, P. Resisting frictional force, mu R. 0.35 R. These are all told last time. Then, sigma Fy0 upward positive plus R minus 30 equal to 0. We got R equal to 30 kilonewton. Quite obvious. By looking only you can tell. See, downward 30 for equilibrium, upward 30. Reaction. Action 30 down, reaction 30 up. Sigma Fx0 plus P minus mu R equal to 0. See, minus plus P minus 0.35 R equal to 0. You already got R equal to 30. Substitute. See, right here. Substituting for R. How much? Equal to 30 kilonewton. Already we got P minus 0.35 30 equal to 0. P minus 10.50. P 10.5. Okay. With this, we got the required answer. If you are writing examination, stop there. Over. That is, with this, we got the required answer. That is, question is what? How much is the least value of P? Yes, with P, how much is the question? Yes, we got the answer. Therefore, the question is closed there. Closed. Then in the class, I went to next question. But then I asked a brain teaser. Note, here sigma m0 is not used. Okay, now, even if it is not used for equilibrium, sigma m0 should be satisfied. I told, see, when a coplanar force system is acting, it is compulsory that sigma fx equal to 0, sigma fy 0, net force in the x direction equal to 0, that is to prevent the motion in x direction, sigma fy 0 to prevent the motion in y direction, and sigma m0 to prevent the rotation. Therefore, if the body, sometime what happens is, sigma fx, sigma fy both are 0. See, engineering mechanics earlier, I told all these, you forgot it now. If sigma fx, sigma fy both are 0, there is no resultant force. But if there is no resultant force, you cannot tell equilibrium. It is possible that a resultant couple may be acting. Then resultant is a couple. Equilibrium is lost because why? Body will rotate. So, but this body, rotating means what? It is not moving, it rotates, see, rotate this way, no. So, sigma m0 is not used, but even if it is not used, for equilibrium, sigma m0 should be satisfied. It is very important, should be satisfied. Okay, then we checked it. by the sketch. See here. P right side 10.5. FF frictional force mu r equal 10.5. See, action, reaction. 30 down and 30 up. Then for check, when you want sigma m0, distances are required. I told this is length of the rectangular block. I took it as 2.4. Actually, I can take L only and solve. But when it is a numerical, it becomes more clear. Remember, with the L, H and B, this will be considered in strength of materials later when you go to direct compressive stress and bending stresses. Very important for foundation or a column subjected to eccentric load. At that time, I won't put numerical. I will go for the bookwork, systematic way, we will derive the equations there. But here, no unknown. See, L, 2.4. I told any length. Height, I told 0.8. Some width is there. See here, our block. Length 2.4. Height 0.8 meter. This width you cannot see. It is, I told, 0.65 meter. Some width required. Okay. Then, in the class I told sigma m0 is not used, but sigma m is equal to 0, any point it should be satisfied. See, sigma m equal to 0 about any point should be satisfied. Okay, start. We selected the point A. See here, this point. Take moment about A. See, 30 into 1.2 clockwise. I took clockwise positive. Again minus 30 into once again. See, these both are collinear. Wait 1 minute. I am telling what all people will write in the Solute textbooks. This is how 99% textbooks they are writing it. See, 30 into 1.2 clockwise, L by 2. If it is L, this is L by 2. Minus anti-clockwise, see, 30 into once again 1.2 plus 10.5 into H by 2. I told you consider the force P to be acting exactly at mid height. You can consider wherever you want. For understanding purpose, I told, see, so far this, in the original question it is not there because sigma m is not there. Sigma m is not required. That's why in the question paper they won't give these dimensions. This is for demonstration purpose. So 10.5 into H by 2 is 0.4. Why? When H is 0.8, I can take not only point, I can take either little lesser value, higher value anywhere, or I can even attach arm here, apply the force there also. Don't bother. Then that's all. See, 10.5 into 0.4 clockwise plus then one more 10.5 into 0. Okay, right here. This is what? This 10.5 is your P 10.5 and again plus, see, one more 10.5 into 0. Why 0? This is your frictional force. Oh, that into 0 because passes. But when you calculate, it is coming, see, 30 into 1.2 minus 30 into 1.2, 0. 10.5 into 0.4 is coming plus 4.2 kilonewton meter. That is sigma m about A is not 0. Instead, it is 4 plus means what? We considered clockwise positive. We found moment. So it is clockwise moment of 4.2 kilonewton meter. Oh, it is not 0. Oh, what is this? How it is possible? I told, because I already told you, equilibrium means sigma m0 should be satisfied. Now, exclamation. What is going on here? You told 0. 0 is not coming. How possible? Class. What is the puzzle? That is the puzzle. Right here. Class. Right here. What is puzzle? That is the puzzle. How sigma m, why sigma m is not 0? Or that means there is something wrong here. So I deliberately made a mistake. I told you, when I asked the puzzle, if I am not making the mistake, then where is the puzzle? I solved the question like 99% people will solve. So there is a mistake. Class. What is the puzzle? Puzzle is sigma m is not 0. It is 4.2 kilonewton meter. This is by taking moment about A. Now, I will tell the reason. There is one more way of asking the question. See here. I will rub some of the portion now. This I will remove. There is one more way of asking question. See here. I will tell you another way of asking question. See. One more way of asking question. That is, for the entire force system, considering action and reactions together, combined effect, sigma fx should be 0, sigma fx equal to 0, sigma fy equal to 0, and sigma m should be 0 about any point. Any point. Now, yes, sigma fx is 0. See here. Sigma fx is 0 because, first of all, sigma fx 0 already over. You can write here. Sigma fx 0 because why? We used it. Plus 10.5 minus 10.5 0. See here. Sigma fx plus 10.5 minus 10.5 equal to 0. Oh yes, satisfied. Sigma fy 0. See, plus 30 upward positive minus 30 equal to 0. So sigma fy also satisfied. Or by looking only you can make out down 30, up 30. Mutually balances. Force point of view. Right 10.5, left 10.5. Horizontally also balanced. But now, when sigma fx and sigma fy both are 0, only possibility which will spoil the equilibrium is a couple. Now see, is there a couple? See, 30, you should write all the statement if you want, or go through the class again and again. See, 30 is acting down. This 30 is acting up. Therefore, see here, 130 acting down, another 30 acting up. So, this 30 down and 30 up will mutually balance. It will not form a couple. Couple will come if the line of action, if the two forces are parallel and separated by a distance. So here, 30 down, 30 up. See here, mutually balances. But see here, hold here, see. 10.5 this way and 10.5 this way. Or you can write here, see, now 30, 30, you can forget it. But whereas, see, now 10.5 this way and another 10.5 this way. This is the P 10.5, this is F of 10.5. It has got a distance between them of 0.4. Oh, see here. Here, moment point of view, 30-30 balanced. It will not create any moment, but 10.5 right, 10.5 left are two equal, unlike parallel forces. You should, those who are serious should write here. Two equal, unlike parallel forces separated by a distance. And if you go back to engineering mechanics, see here, two equal, unlike parallel forces, see, it will form a couple. Two equal, unlike parallel forces separated by a distance will form a couple, will form a couple. And the magnitude of the couple equal to any one of the force 10.5 and into perpendicular distance, that is 4.2 kilonewton meter. Yes, we got it. See how direction, see here. This will rotate how? This way, clockwise. Yes, we got that answer there also. Actually, if the given force system reduces to a couple, there is a rule. Moment of that couple you can find about any point. Not the any, even if you take outside point also, moment is same. I proved it in engineering mechanics. Therefore, conclusion is that I'll write here now, sigma m equal to 0, sigma m equal to 0 about any point should be satisfied, but at present, see I am writing at present, unfortunately, not satisfied. Not satisfied because sigma m, we got not 0, we got clockwise of 4.2 right there. Not satisfied. Then how possible? How possible? How possible? That is, your equilibrium is not there. Is not there. Body will rotate. The rectangular box should rotate. Then all the classes taken so far for support reaction and the entire structural engineering taught by me so far in my life for more than 43, 42, 43, 44 years, and what I am teaching in future for strength of materials and structural analysis, RCC, steel, precious concrete, any subject, everything is wrong. Everything will be wrong because I always tell equilibrium means sigma fx should be 0, sigma fy should be 0, and sigma m also should be 0, but here it is not 0. Therefore, right here, therefore, something is seriously wrong. Seriously wrong. Right. Now I will tell what is wrong. Now I will tell what is wrong or give clarification or explanation or solve the puzzle or give answer to the puzzle. This all you write first of all because it will be satisfied. Sigma m equal to 0 only. Okay, now I will tell why it is that way. 1 minute now. I want the board, this all removed now. Though this all I want to remove, I will start fresh. I want only this diagram. Now I will give the solution or answer to the puzzle. See, 3 times I will tell it. You can call level 1, then level 2, just to understand, see, level 2 and level 3. Level 3 is for high knowledge, see. For those who only know engineering mechanics, what all I tell now, so many things will not be clear. So, I will give the answer in such a way that a person who knows only engineering mechanics or some mechanical students who does not, of course they know little strength of materials also, but no advanced knowledge, or simple way, level 1. And level 2, for those who have little better structural knowledge, especially strength of materials, for them level 2. Level 3 is for those who got extremely good knowledge or those who decided that they will get good knowledge from me now onward. See, if you already decided, oh, this person knows the subject, he knows thoroughly, and he also knows how to teach. What he teaches, we are understanding. So, if you have decided, yes, this is the time for us to learn all the concepts. If you have decided, you come with me up to end of your EM, strength of engineering mechanics, strength of materials, structural analysis. If you are following me throughout and really you are serious and dedicated, if not today, you complete everything, then come back, you will understand. So 3 levels I will do it. So I will tell level 1 now. Level 1 is very simple, but remember, for all the 3 levels, one mistake is, I will remove now. See, for all the 3 levels, irrespective of simple logical reason, see, level 1 is just logical. Level 2 is little strength of materials involved. Level 3 is with little higher knowledge, or you should get later. The mistake is that, see, the mistake, red color I write. Mistake is that, someone has commented, is that line of action of normal reaction will not coincide. See, will not coincide with line of action of 30 kilonewton acting down. Normal reaction of that 30 kilonewton up will not coincide. See, this 30 kilonewton up line of action will not coincide. You can write here. It will slightly, see, line of action of normal reaction R of 30 kilonewton will slightly, how much I don't know, slightly shift to right side of line of action of weight of 30 kilonewton. 30 kilonewton. Shift for this question. That is why, if you observe correctly, see, when I solved all the questions so far, I told you, this sketch 99% people write like this. But see what I have done, if you remember, see, I marked 30 kilonewton this way in all solution, you are not observed. And normal, you see earlier, I slightly shifted here, you are not observed it, see. In all solution earlier, I shifted small amount so that you should not make out. See, it is actually a trick. Cheating, not cheating. I slightly shifted here. See, you see earlier, in all the question, I not, see, this projection I not given. But here I wrote what majority will make the mistake. So, this 30 and this R will shift this side. I will tell the reason why. See, reason. If you stand firmly on the ground, see here, your load is vertically down. Uniform pressure will come if the contact area is very smooth and if the load is transferred firmly through center. See, correctly see here. You should write this one. See, if you apply 30 kN and down this way, pressure from here, reactive pressure will come. The resultant pressure will coincide with 30 kilonewton down, same line of action. So, if you place a block, see, if you simply place a block, if you simply place a block, if the weight is acting down, W, there will be upward pressure, uniform upward pressure will come from here. And it is uniform and the resultant will correctly pass through same line, it will coincide so that there is no rotation. So, if I take this as L, this is L by 2, this also L by 2. This is if the block is simply placed without any horizontal force. But, see now, when you place here, weight acting down W here, some W, and if you apply force P, see now, the block is on the verge of moving to right side. Friction will come here. Friction will come. See, friction will come. Now, see here, I will stand here. I will slightly apply horizontal force this way. I will lean this side. See, suppose you walk. When you are leaning this way, unknowingly, you will put more pressure on that side. See, which side you are leaning? See here. See. You got front side. If you got a good shoes, see, contact of the shoes. Slightly lean, apply horizontal force. See now, it will create high pressure that side and this side less pressure. And if you lean too much, what will happen? Back side will be lifted. Or see here. If you apply, see, vertically down is there. When you apply horizontal force, see here, this way. Or it will create a moment like this. See, it will give more pressure this side. Therefore, since there is more pressure this side, see, imagine pressure distribution is linear. Okay, I will tell that later. The pressure distribution will be something like this. Less pressure here, more pressure here. See, lifting is, if by chance, if this side lifts, equilibrium is lost. Don't go for that case. See, high pressure. Therefore, see, this is trapezoidal. Line of action of resultant will be here. Or it will slightly shift right side. Let it be X bar. X bar. Or, see here, when you apply this P, it will create a moment. See, direct force will compress. Moment will compress that side and lift this side. So that side more pressure. This, see, you see here, you lean this way, see, more pressure. Therefore, higher pressure here, lesser pressure here, resultant will slightly go that side. So it will shift from center x bar, this x bar will be less than. Or by chance in a question, if the force is this way, see now, then what will happen? Then, see, more pressure this side. So then line of action of resultant, see, then you will have more pressure here, less pressure here. It will shift slightly this side. So this shifting is there. So x bar. Therefore, this W and this resultant has got some distance between them. It will form an anti-clockwise couple. That anti-clockwise couple will balance that clockwise couple of 10.5 into 0.4, that is 4.2 kilonewton meter. So the shifting should be seen now. Or I will tell you now. Now if we, therefore this sketch is wrong, write the correct sketch. Correct sketch is, you write the sketch once again. See, I'll give red color for this one now. See, red color. It will be here. Let it be x bar. X bar. By centroid, I will tell later. Now, if you take moment about A, sigma m about A, it will be 30 into 1.2, clockwise positive, plus 30 into 1.2, plus 30 into 1.2, minus R equal to 30 only, see, minus that reaction force R, which also is 30 only, by what, see, equilibrium, downward force equal to upward force, 30 into x bar, then plus 10.5 lateral force P into 0.8, 0.4. This will come 0. Then that x bar should come, see here, x bar. The shifting x bar will come. I will calculate x bar now. See, 30 into 1.2 minus 0 plus 10.5 into 0.4 equal to divide by 30. What happened? Something happened there. Answer equal to. Calculate is answer equal to 1.34 meter. X bar will come 1.34 meter, or this is 1.2, this is 1.34. From here to here, there is a shifting of 1.34 minus 1.2 is 0.14 meter. A shifting of 0.14 meter. Now see what happens. See now. See this horizontal 10.5 P. See now, see correctly now. Horizontal 10.5 P and frictional force. This is horizontal force P. Frictional force of 10.5 this side. This distance is 0.4. Will give a clockwise couple. See, clockwise couple of 10.5 into 0.4 equal to 10.5 into 0.4 equal to 4.2 kilonewton meter. This you already know it. And this downward force of 30 kilonewton and upward force R of 30, once again 30 kilonewton. I told you this is 1.4, this is 1.2. We'll have a distance between them of how much I told? X bar 1.34 minus 1.2 is 0.14 meter. 0.14 meter. This will give, see, a downward force. See, this will give a clockwise couple of 4.2. This will give anti-clockwise couple of any one of the force, 30 into how much? 0.14 equal to 4.2 kilonewton meter. Therefore, if you combine both of them, horizontal forces will create a clockwise couple of 4.2. Vertical forces will form an anti-clockwise couple of 4.2. 4.2 clockwise, see, 4.2 clockwise plus 4.2 anti-clockwise is 0. So sigma m equal to 0 is satisfied. It will be satisfied. Now I told level 1. So now simply if you go to an interview, own engineering mechanics, what you should tell? The line of action of R will not coincide with the downward load. It will slightly shift that side where pressure is more. See, if you try to push the block this side, see, when you move this way, that side more pressure. So it will shift from here. So that shifting will cause extra distance here. Then that extra moment, that see, then it will give anti-clockwise moment, will balance this clockwise moment. That is your level 1. See, this is level 1. Level 1 for those who got only engineering mechanics knowledge. Simple language answer. Okay. Now I will go to level 2. This I will remove now, level 2. So, level 2 also, see. Level 2 also, see now. Don't write 1.34. Okay. Level 2. Right. The sketch written earlier, you should write here, level 2. That is those who got a little medium, little strength of ideas knowledge. See, right here, earlier sketch of, right here, earlier sketch of down 30 here and same line upward R, then this is wrong. Because, reason, see, because if you consider the contact area, right here, this is the contact area. As per our question, it is 2.4, this is 2.4 meter length. Width you cannot see it. If it's the contact area, then see, you see the contact area, there's a downward load acting through center of 30 kilonewton, and see here, this will be 30, and a clock, and there is a horizontal force here. See, horizontal force. This force here, you transfer here. You know it. When you transfer the force from here to here, a couple will come. Horizontal force of 10.5 here. For that one, 10.5 will come here. Friction also. Friction. And also a couple of, this I will call W, this I will call M. M equal to how much? 10.5 into 0.4, that is 4.2 kilonewton meter. Therefore, for the contact area here, lengthwise only, see, for this surface, if I draw a centroidal line here, see, it has got a downward load here of little this side. W equal to 30 kilonewton, W equal to 30 kilonewton, and a couple M equal to 4.2 kilonewton meter. If I take this as A point, this is B point, and then pressure, upward pressure, see. Then you can write here, see. Then, okay, this is much better. Then upward pressure at right side B equal to upward pressure plus W by area, contact area. Area you cannot see here, that comes in level 3. Then plus M divided by Z and upward pressure at B. This is the maximum pressure. Maximum pressure here, see. The pressure will come maximum here. Maximum pressure here. This way. And upward pressure at A equal to, see, plus W by A. What is A, what is Z, I will tell you. Plus W by A, that is direct force, P by A, then minus, because due to force, see, W will press here, W will press here, but M will press there and lift here, minus M by Z. This is the minimum pressure. Minimum pressure, see. Minimum pressure will come here. Minimum pressure. Then the variation is taken linear. Actually, in soil mechanics, it's not linear because of pressure on soil depends upon deformation of the soil. This is linear provided there is no yielding of support. That is what we consider in strength of materials. Now here your area equal to contact area, see level 2, L into B and Z equal to L into B. Area is what? Area is, see, this contact area. The contact, see, level 2, contact area is length into width and Z about, see, when you take this way, your axis comes here, this is axis, Z equal to B into L square divided by 6. Y means strength of materials. B into L square divided by 6 is the contact area, is Z. If you substitute here now, see, less or more here, because of this pressure, net upward force will pass here. W, reaction R. That reaction force R will shift by a distance, so let it be X bar. This is X bar and this is L by 2. This is L by 2. It will shift by a distance of how much? I'll put here now, more neatly. Okay. This is shift, leave it, put that much only to understand. Normal reaction will shift. This is L by 2 X bar. If the load is this way, if it is this way, here maximum, here minimum. Now, see, horizontal P and frictional force Ff by H by 2 will create a clockwise couple of P, frictional force also equal to P only, P into H by 2, and see, of course, reaction R equal to W, remember, and downward load W and upward reaction R equal to W once again, W, this distance will be, see here, this is X bar, this is L by 2, this is X bar minus L by 2, L by 2. This will form an anti-clockwise couple of, see, W into R into what? R into R or W, R into X bar minus L by 2, and these two couples both will be equal, in magnitude, but opposite in direction. So net couple, they will cancel each other, which will maintain sigma m equal to 0 is sufficient for level 2. If you can understand the W by A, etc. Now level 3, remember, level 3 is only for those, level 3 is for those, I will tell you, who has very good structural knowledge, or at least they should think, they think that they got structural knowledge. This is the time to test it. So many people think, they tell always, they will tell, sir, I know everything, sir, almost everything is known for me. I know. When they tell everything is known, after some time they will tell, sir, we don't know anything. Okay. Either they really know, or they think they know, or those who are not having decided now that from me they will learn more and more concept and improve the knowledge. So remember, this is more liberal. See, for this one, I will take up the numerical part. Yesterday I told L equal to 2.4 meter. H I told how much? It is there, I noted down, 0.8 meter, and I told B equal to 0.65 meter. I told this dimension yesterday. Actually I can prove it with the LHB only. No, those proofs we will be doing in strength of materials. Here the particular question you are solving. So I will go for numerical only, because if I prove in terms of L, B and H, some will not agree. They will tell, sir, why? I will tell they will be equal. Sir, why are equal? But numerical means it will come equal. Okay. Now, right, here also, right here. Here also, what we wrote earlier, what? See, W here, W how to 30 kilonewton here, and same line R and P here and frictional force here. This sketch is wrong. Right here, the normal reaction, like the line of action of normal reaction will not coincide with this line. This R will shift. Line of action of R will shift. Now we will find how much shifting by basic concept. See, basic concept. Okay. Now, what I will do is, I will put a sketch here first. See, first I will put a sketch here to make more clear. See, I remember, I wrote it down there. Therefore, you consider the contact surface. See, this requires good structural knowledge. If you got it, well and good. Otherwise, learn now. See, write the plan. Write the plan of contact area. Contact area. See, our block is, see here, this way. Remember, this is the contact area. This is L, this is B, this is H. Contact area is L by B. See, L by B. So that is, in the plan, it will look like this. See, in the plan, it will be like this. So I'll put 3 dimension to understand. See, little 3 dimension, it will be like this. Correct is here. 3 dimensional, it is not inclined. See, this is the axis. Because here, for this one, okay, 1 minute now, instead of that way, okay, I'll put some other way. First remember, you write here, first consider the contact length, better, contact length. See, you take this as A and take it as B, that is AB. If I take the contact length here, AB, see now, if P is acting right side here, the P acting right side, you shift it here, P. P equal to 10.5. Friction will come 10.5. This frictional force also is 10.5. And a load W will act here. See, this is your length of 2.4 meter. This is your weight of how much? W I will write here. W equal to 30 kilonewton. And this will be acting exactly at center, 1.2 meter. Okay. Now, if I shift this P here, see, W is acting on the surface here. Don't see R now. Downward load of 30 action, P transferred here. This P will rotate in the clockwise direction. Clockwise direction. A couple M will come equal to P into, it is P into how much? H by 2. Or P is 10.5 into H by 2 is 0.4 is 4.2 kilonewton meter. Okay. Now, this much you write. Now consider, see, this is perpendicular to the plane. Now do one thing. This much you written. Now write. Now consider the contact area. See, good knowledge required. Now consider contact area. Contact area. That is in plan area. Remember, why I should not tell plan area. That is L by B. So if you put the sketch of L by B here, see, our question, I will put numericals. We took L equal to 2.4 meter and B equal to 0.65 meter. So this is your B equal to 0.65 meter. This is your L, see, L equal to 2.4 meter. See, this is the axis, means, see, when moment comes this way, this is the axis, you should know it. Here, this is not vertical, it is a plan. That much knowledge is required. This is the plan contact area, see, plan area. For the plan area, load is acting vertically down, or it is actually acting like this. You cannot show it. Put a dot, P, W. W is acting, see, this is the plan. See, this way, this comes in the foundation. Those who know RCC and foundation, you know all these things. See, in RCC, I am taking right now foundation on in RCC. So many times explained. Again, I told level 3 for those who can understand. See, plan area is this way, contact area, load is perpendicular, moment also you cannot show, still you can show moment like this. See, actually it is like this. You cannot show moment like this. W equal to 30 kilonewton and moment equal to, how much I told? 4.2 kilonewton meter. I will tell A here, B here, C here, D here, or see here, A, B, C, D. Then, okay, this distance is how much? Same. See, these two are we require only total length. Sorry, total is how much? 2.4 meter. 2.4 meter. Then upward pressure on the block from surface, say pressure P at BA equal to, see, this W will press it, upward pressure, so it is plus W by area, then, but moment will, see, when you apply moment like this, back side is lifted. P at A, or see P, or you can write here, it is pressure along AD. It's a uniaxial pressure along AD, to make more clear. AD line is W by A minus M by Z, and pressure along BC, there load will press it, moment also, see, this all comes in strength of materials, is plus W by A plus M by Z. Now here, W equal to 30 kilonewton and M equal to 4.2 kilonewton meter. And then area equal to L into B equal to 2.4 into 0.65. And very important, section modulus Z is, if this is the axis, parallel side to be as it is, B into whatever is the dimension which is cutting the axis, or one crude method is there, how is the moment, that dimension is to be squared. So it is B into L square by 6. This knowledge should be there for you. So 2 equal to B, how much B? B into L square by 6. See, 2.4 into 0.65 is, I will calculate now, 2.4 into 0.65 is 1.56 meter square, and 0.65 into 2.4 square divided by 6 is, see, 2.4 into 0.65 is how much? 1.56. 0.65 into 2.4 square divided by 6 is 0.624. 0.624. Okay. Meter cube. See, area is meter square, section modulus is meter cube. Again, common sense. That much structural knowledge should be there. Okay, now I will substitute here. See, space required for me. If I substitute now, therefore, pressure P along AD equal to W plus 30 divided by area 1.56 minus 4.2 M divided by Z 0.624. Get the answer. And pressure along BC equal, I told, plus W by area is plus 30 by, where is it? One minute, I should check the camera. Have I gone out of camera by chance? No, okay. Plus 30 by area is 1.56 plus, see, I wrote plus m, 4.2 divided by z is 0.624. You calculate this pressure in kilonewton per meter square. Calculate this pressure also in kilonewton per meter square. I will calculate now. Actually, I already solved somewhere there, but numbers are not visible. I rubbed it by mistake. Okay, 30 by 1.56 minus 4.2 by 0.624. It comes to 12.5. This is 12.5 kilonewton per meter square, and that is 30 divided by 1.56 plus 4.2 divided by 0.624 is, it is coming decimal. 25 point, big number. I do not want decimal. So therefore, to avoid decimal, I will do one thing now. I put factor form. 675, so that I do not want decimal. 675 by 26. I want perfect answer today. Kilonewton per meter square. This also I will put same way. It is 30 divided by 1.56 minus 4.2 divided by 0.624 is 125 by 26. What is this one? 30 divided by how much? 1.56 minus 4.2 divided by how much? 0.624 is 25 by 2. This is 25 by 2 kilonewton per meter square. Okay, now very important concept. Okay, I think I should remove this sketch because some more calculation is there. See the sketch correctly. I am removing this one now. And I will prepare one more sketch now. I got the pressure diagram. See, left side I got 25 by 2 kN per meter square. Right side 675 by 26 kN per meter square. Note, all are in kilonewton per meter square pressure. But now what we want is, now consider only lengthwise, and get pressure or upward load in kilonewton per meter. See how to get it. Again I told level 3. See, 1 minute now. I will tell here. Therefore, if you consider lengthwise, see, contact length AB, right here, you are considering contact length AB of this distance, how much? 2.4 meter. There is a downward load here of 30 kilonewton, which is exactly at 1.2 meter from here, center, and a clockwise couple of 4.2 kilonewton meter, and upward load will act like this. How much is the load? See, we want in kilonewton per this meter. Little concept required. So if that concept is not clear, this is level 3. See, you should make a note. Actually, those who are coming to my RCC class, it is told 1000 times. See here. When we now we want only lengthwise. See, you consider 1 meter length here. 1 meter. 1 meter length here. Width is 0.65. This contact area is 0.65 into 1, or whenever you write here, whenever you got a pressure diagram in kilonewton per meter square, you should write it. See, you are supposed to know it. This all I will tell in strength of material, RCC, very crystal clear, very slowly I will tell. So whenever you got a pressure diagram in kilonewton per meter square, and if you want in a particular direction, see, lengthwise or widthwise, lengthwise. If you want the net upward load due to pressure, then see, pressure equal to force by area. Pressure is basically force by area, or force equal to pressure into area. Force equal to pressure into area. 1 meter length of the lengthwise area will be 1 into width, or whatever pressure you get multiply by width b, you will get upward load or upward pressure or load in kilonewton per meter. Therefore, here left side it is 25 by 2 into 0.65. See, 25 by 2 is in kilonewton per meter square into 0.65. Right side is here. Upward load is 675 by 26 into 0.65. Common sense. See, when you want 1 meter length here, the area contact area is 1 into B. So pressure into area will give the force. 1 is not required. So when you multiply the pressure with the width, it will give the force in kilonewton per meter length. So this answer, I think it will come round number now. Where is the calculator? Here. See, the complications are there. See, first I told simple logic. That is sufficient for majority of you. 12.5 into 0.65 is correctly coming 8.125. 8.125 kilonewton per meter. This load coming 675 by 26 into 0.65. See, suppose it is not clear, then why you came here first of all? I told level 3 is for those who got good knowledge or those who are going to get good knowledge from me in future. Wait for some time. It is 16.875 kilonewton per meter. Therefore, this upward load here at A and B here, if you want only load lengthwise, width effect to be cancelled, it is 8.125 kilonewton per meter. Here it is 16.875 kilonewton per meter. Now, right, next statement. Because of this upward load, its centroid will be somewhere here, centroid G. Why? See, if both are equal, centroid is at center. But since they are not equal, little more load this side. So let through the centroid G, a net upward, the normal reaction will act there. See, the net normal reaction R, you write here, resultant force, resultant normal reaction. See, resultant normal reaction. And this distance, let it be x bar. Now I should not explain because you know it. Resultant load due to varying load is given by, I already told in engineering mechanics 100 times. For a trapezium, the resultant load is given by area of the trapezium. That is, you should write, now I will not tell. 8.125 plus 16.875, sum of the two parallel sides divided by 2 multiplied by total loaded length is 2.4. This will give you the resultant force R. Resultant force R for uniformly varying load. I already uploaded class, how much I explained. See there, how much I explained. Is exclusively types of loads, marathon, class after class, 10-15 times. Area of trapezium is sum of the parallel sides 8.125 plus 16.875 divided by 2 into 2.4. Exactly 30 kilonewton. Oh, correct. 30 kilonewton, and that x bar will be equal to, where resultant will come, centroid from here is, you know it, this side plus twice of that side. See, this all I told you earlier. If you are not studying properly, don't come to my class, I will tell. Or don't go to this level 3. If you are centroid from here, 8.125 plus twice of 16.875 divided by sum of the two parallel sides 8.125 plus 16.875 into distance between the two parallel sides is 2.4 divided by 3 will give x bar value. X bar will come. Why should I calculate? I know the answer. If answer is not coming, I am going to stop my teaching. 5 plus twice of any I am calculating only one reason. Suppose there is a calculation mistake, I can make out now. 8.125 plus 16.875 into 2.4 divided by 3 is 1.34 meter. 1.34 meter. Oh, therefore, now write a last sketch now. See, now write the last sketch and close the discussion. See, last sketch. Therefore, you write here, the normal reaction R, earlier we coincided with W is wrong. See, W is, weight is acting at 1.2 meter, but normal reaction is acting at x bar equal to 1.34 meter. It will slightly shift that side. Or, see, you finally write free body of your block. If you write finally free body of your block, see, through center, a weight 30 kilonewton. 30 kilonewton weight. Okay. This is the total length 2.4 meter, I told. 2.4 meter. This is exactly 1.2 meter, center. And there is a force here of P equal to 10.5 kN we got. A frictional force limiting case of also 10.5 kilonewton, and project this one. Earlier we made the mistake of marking R here. R is not there. It is 1.2. It is slightly this side. See, this is the normal reaction. R equal to how much? R equal to 30 kilonewton once again. And distance from here is, if I take the point A here, it is x bar equal to 1.34 meter. Okay. Now write the sketch. Now write. Now, see, start. See, learning there is no limit. See, I will tell you, nobody told me all these things. I know what is the pressure variation diagram. I know how to find pressure. All this concept, nobody told me. Nobody told me, and I have not come to the class prepared. Okay, now start. Sigma fx, you write plus 10.5 minus 10.5, right side positive, plus 10.5 minus 10.5, 0. Sigma fy, upward positive, plus 30 minus 30 equal to 0, and sigma m about any point. See, any point, actually any point you can say about A, equal to clockwise positive, 30 into 1.2 clockwise minus, this is your what? Weight 30 minus another 30, red color 30, that lead color 30 into 1.34, this is your reaction R. This is anti-clockwise, plus 10.5, that is your P force, into, this is 0.8, I told already, not required, this is 0.8, it is spoiling the diagram, okay. FF equal to, I don't want to spoil it, FF equal to how much? 10.5 kilonewton. See, right somewhere here. P. Total height we took how much? 0.8 meter. We considered at center P equal to 10.5 kilonewton. We consider center. So you can center. See, if you shift the force P, pressure will change, distance will change. Suppose as you take this more and more that side, resultant will come more and more that side. Okay. Then plus 10.5 into 0.4 equal to Why should I calculate? Okay, 30 into 1.2 minus 30 into 1.4, 1.34. See, 1.34 plus 10.5 into 0.4. What is this one? 30 into 1.2 minus 30 into 1.34 plus 10.5 into 0.4. 0. 0. Oh, now that troublemaker sigma m equal to 0 is satisfied. Or one more way of what? Balancing. See here. One more way of verification is, see here. You should write vertically down 30, up 30 will balance each other. Horizontally, right 10.5, left 10.5 will balance each other. But horizontally, right 10.5 and left, this is P. And this one more frictional force of 10.5 separated by 0.4 meter will create a clockwise couple of 10.5 into 0.4 is 4.2 kilonewton meter, and vertically downward weight of 30 kilonewton and the normal reaction upward of also 30 kilonewton. Distance between them is, see, this is 1.34, this is 1.2, means this distance is 0.14 meter. 0.14 meter will create an anti-clockwise couple of 30 into 0.14 is 0.42 kilonewton meter, or the net couple is 0. Why 0? Because, right, clockwise 4.2 because of these two. See, this way, anti-clockwise, see, these two will create, see here, these two will create clockwise couple. These two will create anti-clockwise couple. So, clockwise 4.2, anti-clockwise 4.2, 0. Therefore, now sigma fx 0, already clarified 0, sigma fy 0, and the troublemaker of sigma m 0, all sigma m 0, all are satisfied. So, system is in equilibrium, and the mistake you made is line of action of R. You wrote by mistake coinciding, but actually if you see my, now go and see my earlier classes, I slightly shifted, small shifting I made so that you can't make out. And see, if sigma m is not used, see, almost 99% textbooks, they write here. But they are escaping because sigma m they are not applying. People like me will ask question. Or you should ask question. See, when somebody will ask question, they will tell somebody told me complementary shear. I told him, what complementary shear? Do you know what is complementary shear? He told that if you apply a force this way, some shear, that is internal. I will tell, if you do not know, don't talk nonsense. Not complementary shear. Okay. Therefore, I have given the answer for puzzle. First round, simple language. What? When the block is moving this side, see now, more pressure that side, so line of action of resultant will shift that side, that will create the balancing couple. Okay, that's all. Second one is that theory of P by A and M by Z. Last one, level 3, is complete explanation, including numerical, and perfectly getting the answer. So, at least understand the first one as a logic. So, simply telling that what? Resultant will not pass to center, that somebody might have told it. I know. Some people will tell it. People are no, this is not a, see, this is not that much complication. Some will tell, sorry, complication. Okay, for your level complication, I think at least 5% people can tell the answer. But my brain teaser, so far, nobody told answer. So I thought this question does not deserve a place in the elite club of brain teaser. So I decided There I will put real brain teaser, where you should scratch the head like anything. Already 3 given, nobody answered so far. Now go and answer there. Go to playlist, see there, brain teaser. Now answer. One of them is Verigno's theorem. Second was UVL, kilonewton per meter. Where is that meter? Last one is real master question. In Kannada, I call it Brahmastra. Real master question. Ultimate weapon, the last one. Furthermore are coming up, slowly it will come. Okay. So this class, from course point of view, this class is not wasted actually. You can ignore it, but for learning purpose, this class useful. Okay. We'll continue in the next class. Thank you.